Hey guys, Sarah here. So I know, long time no see. I have been on vacation, which was desperately needed. So I know that there's been a huge gap between videos here, and I'm sorry for that, but I desperately just needed to get out of town and not even think about doing anything that related to work for a while. But I'm back, and today we're actually going to be talking about the PIED gene in corn snakes. I put a poll up on Facebook for you guys to vote on which one you wanted, and PIED was the one that got the overwhelmingly a top number of votes. So we're going to be talking about PIED today, and I'm going to do this to the best of my ability, based on research that I have done in the past and currently on PIED. I've never actually worked with PIED myself. It's just never something that I really cared too much for. A lot of people really like the PIED look. I just never really liked it too much, so I haven't personally worked with it. But I've done a lot of research on it, and I read a lot of articles, a lot of forums, and I'm actually going to be going through what I put in my book when I did the research for it. This is actually my first book, which is available on my website in ebook form. I'm going to be reformatting it. This is what it looks like right now. I will be reformatting it so it's a little bit user-friendly in the future. So there's not going to be any more printed copies for a little while, but as soon as this is reformatted and done a little bit, like I said, more user-friendly, and there's a few mistakes that need to be corrected, just like spelling errors and stuff. I didn't exactly have an editor when I wrote my first book, so just pardon any tiny mistakes that are in there. Regardless, I'm going to be going over the PIED section of the book, and there you can see a pied-sided corn snake. This is just a partial body, so there's the head, and it wraps around here, and then the rest of the snake would have wrapped around like this. This was actually a female that was around some eggs, but you can obviously see she's a diffuse, and she has this white side here, this pied-sided, which is what PIED, this is like a medium to high expression pied. Okay, so now that you've seen what a PIED looks like, I'm going to just go over the stuff in the book that I have here. This was all really heavily researched, and actually some of the things that I researched for this book are now deleted online, unfortunately. There was a website called, I think Seacorns, was like a Seacorns forum, and it just sort of disappeared, and a lot of this information was on there when I originally started researching for this, so this information is unfortunately sort of lost to the Seacorns forum that no longer exist. So I'm glad that I at least was able to read it and write it down back at that time before it's all gone, so that I can relay it to you guys. And I'm sure that some of this information is out there somewhere. If I can find links, I will put them in the description, but for now I'm just going to kind of read for you what I've already written down. And essentially, back in the early to mid 2000s, there were originally two different strains of PIED. There was the SMR strain and the McDonald's strain, and they kind of cropped up on their own in different diffuse lines. So SMR and McDonald, they decided to get together and breed their two strains of PIED together to see if they were compatible. And that kind of worked, but it also kind of didn't. They found out that the two strains of PIED probably are the same, but PIED is very weird in that you can breed two PIEDs together and not get any PIED offspring, at least not visually looking obvious PIEDs. But then you can breed, there's obviously two het PIEDs together and you can get PIEDs. So PIED is considered to be a recessive gene that's only expressed within the diffuse gene as well. So in other words, PIED really can't express at all unless you also have the diffuse gene. And essentially the reason for this is when the snake is in development in the egg, the color and pattern start developing from the spine downward. And if you have the gene mutation diffused, that can slow the progression of that happening, or potentially even stop it from happening, which is why diffused don't have any belly checkers, because it slows that so much that diffused corns just don't have belly checkers. I talked about that in a previous video when I talked about diffused. I'll put that up in a card if you guys want to go watch that. And then it also prevents the pattern on the diffused sides from becoming a fully fledged pattern, which is why a diffused is what it is. Now PIED does the same thing, only for color instead of the pattern. So diffused is more of a pattern trait where it prevents the pattern from moving all the way down onto the belly, but PIED kind of works with diffused where it will actually stop the color from going all the way down, which is why you get the pied-sided look because if it starts at the spine and it's moving downward and then it stops, like it just doesn't go all the way. So that is what causes PIED to happen. So they're highly varied. So some PIEDs are going to look very, very extreme, where you're going to have these really like high white sides here. This goes up at least halfway, maybe more in some places. And then you're going to get some that barely look like they're PIED at all. And in fact, the PIED may only show up like on the face. Sometimes you'll see diffuse corn snakes that have like a white face or white speckles on their face or chin. It might come up on their neck just a little bit, and sometimes that's still considered PIED. Sometimes it's not. Like, you should probably still test for the gene just in case. But PIED can be so varied that you almost can't see it at all, and then sometimes it can be like really, really high up on the body. Kind of the most people who work with PIED, what they want to do the most is get like a completely white-sided snake, or maybe even get the PIED to come all the way up to the peak. And that has happened a few times. I've seen a few corn snakes that had that. However, most of them don't live for some reason. It seems like the most extreme, like fully white, I don't want to say fully white-sided, but when the PIED, where the color would normally start at the spine, it maybe just doesn't happen at all in certain areas of the spine. And so that whole area from the spine all the way down doesn't have any color. That's sort of what they're trying to do. So comparing to what I have here, people are trying to prevent the color from moving downward at all, and they want the white to sort of meet up at the top on both sides of the snake's body. And that's a really cool goal. I think that'd be really cool to have that. But the few people that I've seen online that have accomplished anything similar to that, the babies have not lived. So I'm not sure if there's some sort of like fatal aspect of that. I'm not sure. We'll hopefully see in the future something, we'll get more answers as time goes on. Hopefully it's just a fluke that something like that is fatal, but we'll see. Anyway, so I'm going to continue talking about the breedings of PIED. So you can breed an SMR PIED to a McDonald PIED and still get PIEDs, or you may not get any PIEDs, or you might get like some really high expression PIEDs or some really low expression. When I say high expression, I know I might have mentioned this, but the higher up the white is on the body, the higher the expression. So the really, really low expression PIEDs are going to be ones that you just barely see any white on the sides, and like I said, just ones that have white on the face or just a little bit here and there. That's usually a lower expression. And then the higher it is up on the body, or the higher percentage of white there is, the higher the expression is. So because of the highly varied expressions of PIED, it became really difficult to determine whether or not it was recessive or whether or not it was just maybe a part of diffused. It actually is now considered to be recessive, and it sort of, I don't want to say it's like carried with diffused, but it's only able to express with the diffused gene. So when you are breeding two together, you can breed two PIEDs together, possibly get some PIEDs, possibly not, but you can actually breed, like let's say you breed a PIED-sided diffuse to a normal, and then you want to breed two of those offspring together. So you'll have normals that are het for both diffused and PIED, and if you breed those two together, you're going to get some diffused, some normals, and you're probably going to get some PIED-sided diffused, but you're also going to get some technically genetic PIED that are not actually diffused, so you can't see the PIED, even though it is homozygous PIED. So that's a really weird thing there. This is a homozygous gene that isn't visible unless you have another gene that's also homozygous along with it. So, and when I say homozygous, for those of you who don't know, that just means it's on both sides of the DNA. It's inherited from both parents. So you can have normals that are het for PIED, but not het for diffused. And you're not going to be able to see that PIED unless you breed it back into diffused lines. And it's the same way if you have a homozygous PIED that doesn't visually have the diffused gene. You're not going to be able to see the PIED gene, and you're not going to be able to see it unless you breed that into a diffused line again. So the PIED is just a very strange one, and one of the biggest issues when they were first trying to prove it out was the mask gene. The mask gene was not 100% confirmed to be its own gene until after PIED was actually confirmed to be a gene on its own. And it actually made things really difficult because a lot of masks, especially super masks, also known as homozygous masks, they look very diffused. I mentioned that in my other video on masks that I've already put in a card earlier. I know I said it was about diffused, but it's kind of about both diffused and masked. Regardless, so if you're interested in that, definitely go find that video and watch it, because mask is a very interesting gene. But because sometimes super masks look like diffused, people were breeding what they thought were diffused PIED to other pied-sided diffused and not seeing any pieds, and that can be very, very confusing when you're trying to prove something out. But that's because the mask gene does not do everything that the diffused gene does. So just because you have a mask does not mean that you are going to be able to see pied-sided if you combine it with mask. So the mask gene really inhibited the progress of figuring out if pied was actually a gene. Once they determined that mask was its own gene though, and they sort of, I don't want to say they bred it out, but they made sure that they were only testing with homozygous diffused snakes, then it became much more clear that pied was its own gene and that it was most likely recessive, and that it's only visible when you have diffused as well. So that's just sort of an interesting tidbit of information there, that we actually had the mask gene that was inhibiting the progress of learning anything about the pied gene, because people thought they had diffused when they actually didn't. So just to recap everything that we've gone over, PIED is considered to be a recessive gene that's only visually possible, with the diffused gene also being present visually. The lower expressions are, they sometimes don't even look like they have any PIED at all, and if they do, there's just little tidbits. And then the higher expressions are ones that have the white higher up on the body. There were two different strains of them. I keep saying strange instead of strains. There were two different strains of them, and they were proven to be the exact same gene after much test breeding, and some of that test breeding being slowed down because of the mask gene kind of being in the way there. But now that we've got it out of the way, we know that the two strains of PIED were actually the same gene, and that it is recessive and only visual with diffuse. So I hope that that sort of answers everybody's questions, and I hope that this was like a sufficient video. I know that a lot of you guys have been requesting this video for a while, so I hope that it, met your expectations. If there are any in particular that you would like to hear about in the future, any different morphs or genes, or any more details on different morphs that I've already done, let me know in the comments. And if you haven't subscribed yet, please do. I would really appreciate it. I know that it's kind of awkward to ask people to subscribe, but I know that at least 50% of my audience is not subscribed, and I would really love to see you guys subscribed and to see you guys in the next video. And if you're supporting someone, or at least if I'm supporting someone by watching their videos but I'm not subscribed, I usually feel bad. Just today I subscribed to somebody. I was like, oh, I've already watched 5 of their videos, I should probably subscribe to them. It's just sort of almost a courtesy, and it's like, I know I'm gonna watch a few more. So if you've already watched a few, you're gonna probably watch a few more. Go ahead and subscribe, and I will see you in the next video.